Hello everyone and welcome back to Exam Ignite YouTube channel. This is the last video of the series of microcontroller BEC405A subject code, the 2022 scheme of 4th semester. Today I am completing the series of this by ending the module 5, that is module 5 part 2, where I'll be discussing the stepper motors and the DC motor with the PWM. So watch till the end. Let's get started. Stepper motor, it translates the electrical pulse into mechanical movement. So the application is disk drivers, printers, etc. So it has a permanent magnet called as the rotor, and also called as the jack, which is surrounded by the stators, that is 4 stator windings with a center tap. This is commonly referred to as a 4-phase or a unipolar stepper motor. So center tap allows a change in the current direction in each of the two coils when a winding is grounded. So step angle, it is a minimum degree of rotation associated with the step angle. The direction of rotation is dictated by stator poles, and the stator poles are determined with the current sent through the wire poles as the direction of current is changed, and the polarity is also changed, causing the reversion motion of the motor. You can say step 1, 2, 3, 4. Then the winding A first will be 1, 1, 0, 0, then it goes 0, 1, 1, 0, then winding C will be 0, 0, 1, 1, then for the winding D it will be 1, 0, 0, 1. So what type of question you can expect is it explain the neat diagram, explain the interfacing of the stepper motor using the 8051 microcontroller, that is rotate motor continuously. A switch is connected to pin 2.7. Write a program when it is the switch is 0 and when switch is 1. Switch is 0 clockwise, then switch is 1, then it is counterclockwise. You can observe this is our DS89C4X0, and you have an ULN2003 that is connected with a unipolar stepper motor. We are having resistor, and you can observe the 8051 connection to the stepper motor. In the program, you can observe firstly you have to load the step, that is 66H into E, and that is move to a port 1. Then rotate right, that is move it clockwise. Call the delay and go back to SM, short jump to back loop. So let's go to that. Before that, you have to make a delay subroutine that's saying that move R2 to 100 to R2, then move 255 to R3, then DJNZ, that is decrement R3 comma H2, then DJNZ R2 comma H1, then return. So for that is was for the switch 0. Now for the switch 1, if it is 1, then you have to write ORG 000H. Then you have to first set P2.0 to make it take an input. Then start the value by fixing the value 66H2A, move it to the port 1. Then start a loop turn JNB, that is P2.0 clockwise. Check the switch value. Rotate right. Then delay it. Then move the value to the port, then SJMP turn. So keep on continuing this until it satisfies the JNB jump instruction. Then CW, that is clockwise. RL, rotate left A, then call the delay, move it to the port A, short jump. So finally write the delay subroutine. So next comes DC motor interfacing. A DC means it is a direct current motor. It is another widely used device that translates electrical pulses into mechanical movement. So DC voltage connecting to positive and negative leads of a DC motor. By reversing the polarities, DC motor will move in the opposite direction. So example is a small fan used in the motherboards to cool the CPU. So this is a difference between the DC motor and the stepper motor. Go through the difference so you can have a clear knowledge of the concept. So when the motor moves clockwise and a motor moves anti-clockwise, first it is connected to the positive and the signs get changed. The speed of the motor will depend on the 3 factors. One is load, voltage, and current. So for the given load, we can maintain a steady speed by the method called as PWM, that is pulse width modulation. So by changing the width of the pulse, we can increase or decrease the amount of the power applied to motor. So thereby increasing or decreasing the motor speed. That is, wider the pulse, higher will be the speed. So this is first line indicates our 25% DC, that is 1/4 power. Then comes the 50 power DC, that is half power. Then 75% DC, that is 3/4 power. And last one is 100% DC, that is full power. This is our PWM comparison. Now comes the interfacing with the 8051. 8051 interfaced with our motor, DC motor. So this is what our connection is. Connected to port 1. And now comes the C program, where we have to write for the switch 0 it is clockwise, and for the switch 1 it is counterclockwise. Hash include register 51.h. Then S bit, that is switch is connected to what? This port 2.7. Next, enable, that is PWM is generated pulse from the 8051 to opto-isolator initially connected to port P1.0. Next comes a motor, that is motor 1 to P1.1, then motor 2 to P1.2. Start the main, void main, then mark it as switch as 1, enable 0, then my motor 1 will be 0, motor 2 will be 0. Then while the loop has to get started, when if enable is 1, then we are having two cases. One is if and else condition. If the switch is equal to 1, then motor 2 is 1 and motor 1 is 0. If the or else the condition is false, that is if switch is not equal to 1, then motor 2 is 0 and motor 1 is 1. So this was about our C program. And there will be a special case, they will mention with the duty cycle pulse, that is 50% and 25%. Then you have to write a slight changes will be there, where you have to mention ms delay 25, ms delay 25, and ms delay 50 and ms delay 50. So this was about that. Now coming to some other important programs, you can go through this. I'll scroll up, and please do not, these are some of the expected things that you can think. Then after reading that, you can continue reading this. So that those things are most important, and then you can go with these programs. So firstly, LEDs are connected to bit port 1 and port 2. Write the C program to that shows a count from 00 to FFH on the LEDs. So this is our C program, and this is for our port 1 will wait for half second, and then it will send it to port 2. And this is our C program, where a byte of data from port 0, it is less than 100, is sent to port 1 or port 2. Then similarly goes with this program. Then this is also an important one. A door sensor is connected to P1.1 and a buzzer is connected to P1.7. So you have to write a C program to monitor the door sensor, and when it opens the sound buzzer, you can sound the buzzer by sending a square wave of few hertz, 100 hertz. So this is an application question which you can expect. Okay, next comes, this is also an application one, where you have to send the in the LCD, it has to print the earth is but one country. So this is having 28 characters, and this has to get printed. So you have to make an C program for that. Similarly, you have to toggle all the bits in the P1, P0 and P2 continuously with the delay. So this is also an application one. Finally, the C program to get the status of the bit P1.0, save it and send it to P2.7 continuously. So this completes my complete series of the microcontroller that I had started. So go through all the modules and do well in your exam. Thank you for watching. Do like, share and subscribe to Exam Ignite. Thank you.